Okay, so I claim that turbulence is a surface inside the water, and now I have found that the vortex makes a nice shades through light and optics, and these optical conditions verifies that this surface exists. So here is a cut about the water vortex. These water flows is completely verified on ink dyes, and that's nothing new, so that's everything in this case is sure. Interesting thing is that there is a flow and inside that it goes around, and in my point of view the vortex forms such surfaces around the inside the water. So and the new thing which was new to me on last days was that there is this toroidal vortex on the top of the vortex, and it it explains the top behavior of the vortex. I mean, the rotation speed is here higher than here, which means that according to Bernoulli, the higher velocity means lower pressure. So here is a pressure difference, and this pressure difference sucks water which overflows through these vortex rings. Okay, so I have other page which now shows how the light bends on the vortex. I have a line here which shows the light when it comes from up, and it bends on the surface, and it might go through the ring and stuff. That's not everything of that is not so much important. The important thing to understand is that the light which goes here and hits the surface goes also always on the side, and on the side the light hits on this surface, and this is the total internal reflection which I mean. So the light have two possibilities. When it hits on this surface, it bends. Let's zoom it closer. It goes directly, it goes through, or it's reflected back. And in all cases, the light cannot reach this area. And in some cases, the light will be catched by the surface, either immediately here or just after the second reflection. This makes the bright ring around the shade. Okay. Then I have been telling about the redshift and blue shift. The rotation here is like this, which means that if the light comes from the side and hits on the circle rotates in this direction, which causes a redshift. So the first reflection and then a second reflection, which means that there is a double redshift, which makes it so efficient. And this, therefore, there is a red ring, and from the other side there is the rotation is against the stuff, so there is a one blue shift and a second blue shift, and therefore the blue edge comes visible. So that's my point of view on this issue. And then there is still one open question. It's this. I think that also in the bottom of the vortex there should be a toroidal vortex to close the concept, but this is quite difficult to verify with my simple bathroom lab equipment. Okay, that's about it. Thanks.